Okay, we are going to discuss hypersonic wind tunnel or hypervelocity wind tunnel. First, we can know the Mach number range for this hypersonic case. And we can note stagnation pressure to attain this Mach number. For supersonic case, we can keep even 1 atmospheric pressure, but for this hypersonic, we can't proceed with this lower value. We can aim for higher values. Ranges from 150 to 1500 psia and stagnation temperatures from 150 degree Fahrenheit to 3500 degree Fahrenheit. Next is about test section. Here we can prefer a solid walled test section. Okay, we study different types of test section. Here we can use solid walled, no holes on any side. We can fix solid wall, and it requires contoured nozzles. In our aerodynamics lab, we changed 3D wing into 2D by ignoring the flow in one direction because we noted little changes in that direction. But in hypersonic case, we can see significant changes in all directions. So we can use 3D nozzle or axially symmetric nozzle instead of 2D nozzle. Okay, next about the model sizing. Okay, we can choose larger model, comparatively larger than supersonic tunnel model. Sometimes the model frontal areas sizing is up to 10% of the test section area. A frontal area is up to 10% of the test section area. Okay, for a supersonic case, we can use scale down model. Here also scale down model is used, but the size, the frontal area of the model, scale down model is 10% of the test section area. Maximum of 10% of the test section area. We can keep it lower to this also. Okay. We know about some complications in the supersonic and hypersonic. In both cases, we can expect the shock wave. This can collapse the wind tunnel. So we can size the model to negotiate the effects of waves produced in the hypersonic flight conditions. The model size will probably be limited by the large model wake, which takes up too much flow area in the diffuser and blocks it during the tunnel starting. Already we kept the larger model. We can see the wake also, so it can block the flow while running the tunnel. So the tunnel wall is unlikely to affect the flow over the model. So tunnel wall, the wake wall, solid fluid interaction, okay, may happen. They are telling about fluid solid interaction in hypersonic tunnel. So hypersonic tunnels use air that is heated to avoid liquefaction during expansion to high Mach numbers. So hypersonic means high speed. So when you expand the flow to reach higher value, higher Mach number, liquefaction The air may change its phase to liquid. In order to avoid this, we can heat the air in the hypersonic tunnel while expanding to attain higher Mach number value and the corresponding low temperatures. Okay, higher Mach number is associated with low temperature. So we can think about these additional facilities in the hypersonic tunnel. Okay. So we can use some heater to expand the Mach number that can keep the air in the same phase throughout the tunnel operation. The use of heated air is the major factor that causes hypersonic tunnels to be more complicated than supersonic tunnels. So when we use heated air, okay, we can see more complications than in supersonic tunnel. The air in hypersonic tunnel can easily be dried to avoid condensation effects due to expansion of air to high Mach numbers and the consequently low temperatures. So first I told we can use heater. So if you use the heater, okay, we need to use the dryer facility also to avoid condensation effect. So if you use heater, the air can be in the same phase, but more expansion chances are there. So we can try the dryer also. This is usually a less serious problem than in supersonic tunnels because in the process of compressing the air to the necessary high pressures for hypersonic flow, most of the natural water is simply squeezed out. Okay, we can squeeze out the natural water when we compress the air to attain high pressure value. So this is not a big problem in hypersonic, but we can take it all into consideration. Okay, we can use heater to keep the air same throughout the tunnel operation, and we can remember of the drying to avoid condensation, and we need to squeeze out the natural water. Okay, and next is theory in hypersonic tunnel. We can use Newtonian impact theory. This theory tells about different forces on the model in the hypersonic tunnel. This theory is based on the premise that a steam approaching an object will import to the object the component of its momentum normal to the surface. Okay, we can see the momentum normal to the surface of the object, and that the tangential component of the free stream momentum will remain unchanged. No change in the tangential component of the momentum. Okay, but the momentum imported to the object in the normal direction can be considered. U infinity, the free stream that can be resolved into two components. One is parallel to the model, another one is perpendicular to the model. Okay, here U infinity sine del can give notable momentum change over the model. Okay, one more time, I like to discuss the hypersonic tunnels. The Mach number ranges from 5 to 10 or higher. The stagnation pressures from 150 to 1500 psia and the stagnation temperatures from 150 degree Fahrenheit to 3500 degree Fahrenheit. Here we can see solid walled test section and require contoured nozzle. Okay, that should be axially symmetric instead of 2D because we can see notable changes in all directions. Forces and moments are changing in all three directions. So we can use axially symmetric nozzle or 3D nozzle. And the sizing of the model should be larger than of supersonic tunnel model. The model frontal areas can be kept up to 10% of the test section area. And the model size can be limited by the large model weight. Okay, the wake will be there, waves will be there in hypersonic tunnel. Okay, in order to keep the wave on smaller region, we can do the model sizing appropriately. The larger model wake can cover more floor area in the diffuser and it can block the tunnel while its operation. The tunnel wall is unlikely to affect the flow over the model. Okay, the tunnel wall is to be designed not to affect the flow over the model. So wake can come, so we can keep the wake in fixing the model size, then only the flow is to be undisturbed. And we can see some additional facilities, heater facility to keep the air in the same place because higher Mach number and its corresponding low temperatures can allow liquefaction, liquefaction. And the use of heated air is a major factor that creates more complications to operate the hypersonic tunnel, though it is small in supersonic case. The air in hypersonic tunnels must also be dried to avoid condensation effect. Okay, otherwise the moisture, everything will be deposited. So we can use a drying facility also to avoid condensation. The dryer can be moisture removal operation. But we can remove the natural water because of high pressure development in the hypersonic flow. So this will simplify the operation. But in supersonic, we can do something to control this. But here excess pressure can squeeze out natural water, so we can't see any liquefaction effect inside the hypersonic tunnel. Here they are following hypersonic flow theory or Newtonian impact theory. This theory encourages the momentum component in the direction normal to the surface of the object. It ignores the momentum in the tangential direction.